Welcome to Statistics, where we bring complexity to clarity. I'm excited to have you join me for our 22nd unit LSD, that is Latin Square Design. Let's begin our journey of Latin Square Design, that is LSD. A Latin square is a balanced two-way classification scheme. This arrangement was originally presented through Latin letters, so it is called a Latin square. When these letters represent some treatments of an experiment, it is known as Latin square design. Here you can see the layout of Latin square design. Let's check out it in detail. Here, number of rows, columns and treatments are all equal. As you can see here in the given example, there are 4 rows, 4 columns and 4 treatments, namely A, B, C and D. Here each letter, that is representing treatment, occurs once and only once in each row and in each column. So suppose if we take example of letter A, that is treatment A here, then it does not repeat across its row or its column. Or if we take example of this treatment D, then it does not repeat across its row or its column. Hence, Latin square design is a two-restrictional design. Here each row and each column is a complete block. A Latin square with P rows and P columns is called P cross P Latin square or a Latin square of order P. In our case, there are 4 rows and 4 columns, hence it is a 4 cross 4 Latin square or a Latin square of order 4. Now, let's discuss randomization and layout plan of LSD. Randomization in Latin square consists of choosing a square at random from among all possible Latin squares. Fisher and Yates gave the complete set of Latin squares for 4 cross 4 through 6 cross 6 squares and sample squares up to size 12 cross 12. Cochrane and Cox gave sample Latin squares from 3 cross 3 through 12 cross 12. A method of randomization suggested by Cochrane and Cox is as follows. The necessary condition is that the treatments are to be so randomized that every treatment occurs once and only once in each column and each row. Reduced or standard Latin square is one in which the first row and first column are arranged in alphabetical order. Let's see it in stepwise manner. The first step is reduced Latin square or standard Latin square obtained by selecting randomly out of 56 Latin squares. Here we have considered 5 treatments, namely A, B, C, D and E in our example, so there will be 5 rows and 5 columns each. As we have taken 5 treatments for our example, there are 56 possibilities of different Latin squares. Hence, we have to randomly select any one Latin square from it. So this is the one which we have selected. The next step is randomization of rows. Suppose the random numbers for rows are 3, 2, 1, 5 and 4. Then we have to arrange the rows in this order. So here you can see that rows are arranged sequentially from 1 to 5, and after the randomization we have to arrange the rows in the new sequence, that is R3, R2, R1, R5, R4 based on the random numbers selected. The next step is randomization of columns. Suppose the random numbers selected are 3, 1, 2, 4 and 5, then we have to arrange the columns in this order. that is C3, C1, C2, C4 and C5. The next step is randomization of letters or treatments. Suppose the random numbers selected are 2, 5, 1, 4 and 3 for treatments. Then, as we know that the letters or treatments A, B, C, D, E are serially numbered as 1, 2, 3, 4 and 5. Hence, based on our random numbers selected, the new series will be B, E, A, D, C, that is 2, 5, 1, 4 and 3 respectively. Hence, we have to replace the treatment A with B. As we can see here, the treatment A will be replaced with B. And similarly, treatment B with E, C with A, D with D and E with C. Thus, after the randomization of rows, columns and treatments, we get the final layout of LSD as this. The shape of individual plots may be square to long narrow strip, and simultaneously the shape of Latin square can also be square or rectangle accordingly. The terms square represent the equal number of rows and columns. The design is very reliable to give precise results when the number of treatments is from 5 to 8 or at most 12. Let's see the statistical model of LSD. It is Yij of k is equal to mu plus Ri plus Cj plus tau k plus epsilon ij of k, where I is equal to 1 to up till R, j is equal to 1 to up till C, k is equal to 1 to up till T, and R is equal to C is equal to T. And Yij of k is equal to response of kth treatment in ith row and jth column. Mu is equal to true effect or general mean. Ri is equal to effect of ith row, Cj is equal to effect of jth column, tau k is equal to effect of kth treatment, and epsilon ij of k is the experimental error associated with kth treatment in ith row and jth column. Now let's see the procedure for analysis of LSD in stepwise manner. The first step is calculation of correction factor, that is CF, which is equal to grand total square divided by T square, where T is equal to number of treatments. Step 2 is calculation of general mean, that is GM, which is equal to grand total divided by T square. Step 3 is calculation of row SS, which is equal to 1 upon T into R1 square plus R2 square plus up till plus RT square minus CF. Step 4 is calculation of column SS, which is equal to 1 upon T into C1 square plus C2 square plus up till plus CT square minus CF. Step 5 is calculation of treatment SS, which is equal to 1 upon T into T1 square plus T2 square plus up till plus TT square minus CF. Step 6 is calculation of total SS, which is equal to double summation I is equal to 1 up to T, j is equal to 1 up to T, Yij of k square minus Cf. Step 7 is calculation of error SS, which is equal to total SS minus row SS minus column SS minus treatment SS. Step 8 is calculation of row mean square, that is MSR, which is the ratio of row SS to row degree of freedom. Step 9 is calculation of column mean square, that is MSC, which is equal to ratio of column SS to column degree of freedom. Step 10 is calculation of treatment mean square, that is MST, which is the ratio of treatment SS to treatment degree of freedom. Step 11 is calculation of error mean square, that is MSE, which is equal to the ratio of error SS to error degree of freedom. Step 12 is calculation of F, where calculated F for row is the ratio of MS of row to ms of error. Calculated f for column is ratio of ms of column to the ms of error. And calculated f for treatment is the ratio of ms of treatment to the ms of error. The next step is step 13, that is prepare ANOVA for LSD. The ANOVA for LSD constitutes of source of variation which includes row, column, treatment, error and total. The degree of freedom for row, column and treatment is t minus 1. For error, it is t minus 1 into t minus 2. For total, it is t square minus 1. The sum of squares SS, MS and calculated F can be computed using the formula discussed in previous steps. Or you can calculate it using the formula given here in this table. Here, this term stands for correction factor. The interpretation of LSD can be given as if calculated F is less than table F at 5% level of significance and treatment DF, error DF, then observed difference is non-significant and except at 0, that is, all treatment means are equal. Whereas if calculated F is greater than equal to table F at 5% level of significance and treatment DF, error DF, then observed difference is significant and reject at 0, that is, at least one pair of treatment means are significantly different. Step 14 is calculation of SEM, that is standard error of mean. SEM is equal to root MSE divided by T. Step 15 is calculation of LSD, that is least significant difference, or CD, that is critical difference. If treatment F is found non-significant, then no need to calculate the LSD or CD because all treatment means are equal. Whereas if treatment F is significant, then calculate LSD or CD using the formula statistic T at 5% level of significance and error degree of freedom into root 2 into SEM. Step 16 is calculate coefficient of variation, that is CV% is equal to in the root ms of error divided by general mean into 100. Now let's see the advantages of LSD. Now let's see the advantages of LSD. LSD is able to control two-way variability which is not possible in CRD or RBD. This brings reduction in error mean square. The analysis of data does not entail any complications. The estimation and analysis in case of missing data is simple. Analytical procedures are available for analysis of data when two or more rows, columns or treatments are missing. A 4x4 Latin square is as efficient as a randomized block design with 5 replications and an equal number of treatments. Let's see the disadvantages of LSD. LSD can accommodate a limited number of treatments. As a practice, more than 10 treatments are seldom used. A Latin square for less than 5 treatments does not provide adequate degrees of freedom for experimental error. LSD of order 2, 3 and 4 may not be as efficient as a CRD or RBD with same number of replications. Thank you for joining me on this journey through our 22nd unit LSD, that is Latin square design. If you found this unit helpful, don't forget to like, share and subscribe to Statistics for more insights and clarity on statistics. Your support helps us continue creating content that makes complex topics simple and accessible. Follow us on Instagram and LinkedIn.